In this tutorial, we will work on the Boston housing dataset. We can reach to the Boston dataset from the First Steps workspace. And we can see the Boston regression dataset here. So first, let's check out the problem description. We can see the summary of the problem. For instance, we are going to predict the target, the column name target, and our problem is the multivariate regression problem. That is, we have many features to where many continuous features to be able to predict a continuous feature. And this is generally a very simple problem, so difficult to level this law. And so we can also get a slight context about our dataset, how it's collected, and what's the main goal. And on the content section, you can see the description of each column for this. CRIM means per capita crime rate by town, or tax means full value property tax rate per $1,000. And as again, we are going to predict the target column, which is the median on Rockbite home value in dollars divided by 1,000 and 10,000. And so we also have the what to do section here, which gives us a simple roadmap. And the first thing we need to check out is that if each column has the correct data type. For instance, here we are given that Chase and RID columns are actually categories, and the others are continuous, which are decimals or integers. And so after checking out our dataset and ensuring that everything is okay, we are going to build a machine model. So let's go to our data. So upon entering my data section, we can see each column and can also see their distribution forces on the CRIM. IM column, which is the crime rate per region. You can see that most of the CRM values are accumulated around this range. And similarly, you can see the distribution of each column. And you can also see the data that, for instance, we have set the CHHS and RADR category column. So we can also confirm that here. And you can also check and change this data that if necessary. But since these are the correct types, you are not going to alter anything. And so after roughly checking our data, we can now see the other section. And we have an AI assistant. You can ask some simple question about your dataset, or what's your goal, for instance. Here I ask how many roots does the dataset have, and it gives an answer that the data has 506 rows, and you can ask different questions such as, I don't know, such as if ID the vertical, or let's say is ID is a vertical column. Well, it can take us a while to be able to answer this question. So here we are given that the ID column is not a categorical column. We can also confirm that here, it's an integer column. So you can also ask another questions to be able to explore your dataset further. And here we have the correlation matrix, which gives the highest of the linear and nonlinear correlation between each two features. For this, we can see that, for instance, the correlation between LSTAT and target is very high, 0.74, and these correlations are within the range from 0 to 1. So 1 simply means that these are the same column from target to target. And we can see from here that LST8 is the most positive to correlate with target. And probably the DIS column is least positive to correlate with target column. And we can see the variable correlation more explicitly on this bar plot. For instance, let's say we want to see how the texts and the target values are correlated. So we can see that as texts are increased, we generally don't see a very too much like at the positive correlation. So we can say that there is a very strict, strong correlation between text and target. And you can check out other console. Let's say there is a text and PT ratio, and we can see again there isn't a very too strong correlation between these two features. And let's now go to train our model. So we are going to predict the target column. And now you may ignore some columns if to be able to train a faster model, or if you are sure that some columns are irrelevant to your target column. But we aren't going to ignore any column for this training. And in the training quality, NextBrain offers you 3 different options. So we have the fast option, which generally trains models under 1 minute. We also have the performance and accurate models. This generally takes a bit longer, but fast generally gives a pretty decent result. So we are going to stick with fast model. And also we have the advanced option. You can add synthetic data to basically have more data so that your model will be able to predict features based on various features. So we are going to also add synthetic data, and NextBrain simply add artificial generated data to be able to generate a more comprehensive and more generalized model. And also can change the optimization metrics. So for this, you may say that I'm particularly interested in R2 score. So you can change this so that the NextBrain will give you the model that gives the greatest R2 score. But we are going to stick with auto model. I'm automatic for this training. And on the train test, you can simply set up the train and test ratio. But 8 to 20 is generally like a conventionally good ratio, so we aren't going to change this either. So let's not train our model. It will generally take a few seconds since we are training a fast model. But our model is now starting. After starting, it will generally take around 10 seconds to generate a model. So the training is done now. We can see that our model has achieved a 94% accuracy, which is a pretty decent model. And we can also see some suggestions. NextBrain provides us to score even further better results. And so we are told that we can ignore those columns, because this column apparently has little to no influence on the target column. And we can also see that we can simply drop the IT column because it's just the roll number. So it again has no importance to the target column. So and the other suggestion is that these two columns are correlated with other columns. So since our model is LDN regression model, dropping these columns will have no effects on the final results too much because we already have another column that can simply imply those two columns. And we can also see the column importance graphs here. We can see that LSTH column seems to be the column that has the most influence on the target column. And we can see the influence it has on the target column on different features. For instance, for the range between 22.56 to 41.99, we can see how it influences the target column, and the green color here means that it is positive, the correlates. And if there was a red color, it means it's negative. The correlates, that means it generally implies that the target column will already is on that range. And you can see the column importance for other columns as well. For instance, for the PT ratio, you can change these ranges here to be able to get a plot peak about what will be the target column for different ranges on each column. On the other point, we have the visual explainability. This is simply a binary theory. We ask a simple yes or no question to be able to get the distribution of the target conformance. If the LST8 is greater than 7.79, we will go to the right. If it is not, we will go to the right. And by following the simple questions, we can get the distribution for us. If LST8 is greater than this value, and also greater than this value, so if it is greater than 37.82, this will be our final target distribution. We can see that around 50% of target will be between range from 5 to 5.03. And similarly, you can get distribution based on the distribution of these features. And we also have the model process. We can see that we are simply given the roadmap. NextBrain follows to able to generate a model. First, we can see that we have iTransform, which may include a process like determining the data types of each column, or then we have the data fit doing. For instance, we may drop some rows that have no values. And so we also have the out there detection. NextBrain may drop some outliers to be able to generate a more generalized model. And we also have data scale. And the data will be scaled so that the right order, very like extremely small values, don't skew our final results. And also they have the time features. Now, for example, the data isn't a time series. So we didn't perform any time features. But if the data contains any updates column, the explain will simply try to generate a time series data, and will set a scene to data. We add artificial generate data to populate our data. And then as a final step, we have the training and test split to get the final results. And we can get more insights on the dashboard. So let's go to dashboard. And so we can see for advanced statistics section here, the final metric results for both training and testing. For us, we can see that on the training, our precision is around 97 on the test set. Set is 94. And similarly, you can get the metric results for other metrics such as means to have blog error or R+ score. You can see also the column importance graph here. And again, if you aren't sure about what this plus exactly mean, you can click on this I symbol here to get a more comprehensive report about what this plus try to tell. So let's close this chat for now. So we can see that LSTH column seems to be most strongly correlated to the target column. So we can simply get a very good picture about the target column based on the LSTH value. And we can also get what are the predicted and actual values here. So for a perfect model, these points will be located on this line, on this straight line. So we can say that our model isn't like a very perfect model body. It gave a very decent result. We can see, for instance, for this particular point, the true type value is 17.97, but our predicted value is 2.8. And you can see also, for instance, for as the true target value increase, we can see that our predicted values seem to be a slight off. So you can examine your model further or to even get further better results. And we also have the pure symmetric here. We had already examined this pure symmetric on the first section, and we also have the Sankey diagram here. This is simply as a workflow about what will be the target failure based on different features for 68 is between 75 and 100. And LSEA2 is between 1 and 2. And it said if you follow a similar range values, you'll be able to tell what will be the final target results. And on the final visual explainer, to take a graph again, you can see what will be the distribution of target like based on the split between a split of a column. For if LSEA2 is greater than this value, this will be our final target distribution. And if it is smaller than this particular value, you can see that 77% of target value will be in the range between 41 to 50. So finally, you can also make new predictions after entering values for each feature the model has trained on. So this was a simple, like a general overall workflow of how NextBrain train models. See you on later tutorials.